Okay, so this is Edexcel GCSE 2022. It's question 19 to the end. Now I've already written in the answers, and that's because I taped it yesterday and it didn't record at all, or 30 seconds did, so I don't know what happened there. So I'll just read through my answers. So you might need to pause it because obviously I'm not writing, so I'll be doing it a bit quicker than if I was writing as well. Okay, so I'll read the questions and then read out my answers. I can check my answers as I go along as well then. Right, PTQ is a diameter of a circle, means it goes through the centre. RTS is a chord. T to Q there is 3. S to T is 4. T to R is 12. Calculate the radius of the circle. So the radius is going to be half of this diameter. It's going to stop there somewhere. Okay, so TS, the way this works, T to S is 4/3 of T to Q. That's a known measurements that we know. So this one, 4/3. If we divide this by 3 and multiply by 4, we'll get, that's how we get from T to Q to T to S. Now P to T is therefore 4/3 of R to T, or T to R. Okay, so it's 4/3 times 12, which is 16. Okay, so we know P to T is 16. So now we, that one's 16. All the way, so that's beyond the radius. Well, we think it is anyway. Well, it is, because I can see it's 16 plus 3 is the full diameter. So the radius is half of the diameter. So it's 19/2, 9.5 centimetres. Right, question 20. The histogram gives information about the heights h centimetres of some tomato plants. There are 12 tomato plants between, so this comes up later in the question, so ignore that bit now, between 75 and 85. Okay, so those 12, inside that box there, that area represents 12 plants. Okay, in there. One of the plants is selected at random. See that 12, that's going to give us the clue to be able to work out how many plants in the sample. One of the plants is selected at random. Find an estimate for the probability that the randomly selected tomato plant has a height greater than 82.5. Look, I marked that on yesterday. 82.5. So it's 75, 80, 85, so halfway there. Okay, so all this is set out here. So the 75 to 85. Now, when you've got a histogram, the area of the blocks, of the rectangles, represent the number in that category. So the area is 12, because there's 12 plants in that rectangle. And we've got a base of 10, so therefore our height is 1.2. Okay, so we can read off here. That height has to be 1.2, because base times height has to be equals to 12. Okay, so you can look at the scale then. So, and if you work out the scale, that's 1.2. 2 small squares is a 0.1, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1, 1.1, 1.2. Okay, so you have to get that scale right as well. Okay, so that's what I've written there. 24 small squares makes 1.2. So 2 small squares is 0.1. If you do 1 small square, it's 0.05. That's a bit fiddly to write those in, so we do 2 small squares is 0.1. So now we need to work out the total plants in the sample, which is the total area of the rectangles. So 55 to 6, I'll put these in first of all. 55 to 60, 60 to 70, 70 to 75, 75 to 85, that's one we know already. And then 85 to 90. So the base, with these are rectangles, 5, 10, 5, 10, 5. That's looking at these. 5, 10, 5, 10, 5. And then the height, it's using this scale here. So this one's 0.6. This one's 0.8. This one's 1. This one was 1.2, and that's one we knew already. And then this one is, where is it there? 0.4? Yeah, 0.4. Okay, so for the area, base times height, each of these, 5 times 0.6 is 3, 10 times 0.8 is 8, 5 times 1 is 5, 10 times 12 is 1.2 is 12, and 5 times 0.4 is 2. And then we add those up. So that's the total in the sample is 30. It's all those added up. Okay, so it's going to be out of 30. So we need to work out how many plants are, as an estimate of the number of plants that are greater than 82.5. So it's all these here. So this orange bar here, this first bit here, that's a quarter of this 12. So that's 3. Quarter times 12 is 3. And in there, it's 2. So 3 plus 2 is 5. So they're greater than 82.5. Greater than or equals to. So it's 5 out of 30 or 1 out of 6. Okay, question 21. Part of the graph of y equals 2x squared minus 4x minus 1 is shown. So ignore this straight line, that comes up later. Use the graph to find estimates for the solutions of this equation. So it's the graph equals to 0. And they happen where the curve, when it's equals to 0, is where it crosses the x-axis there. And it's minus, got to get the scale right, minus 0.2 and plus 2.2. Now by drawing a suitable line on the grid, find estimates for the solutions of the equation x squared minus x minus 1 is 0. Okay, I'll take this colour out because I can get carried away with my highlighters sometimes. Okay, so we've got the graph of 2x squared minus 4x minus 1. We want a straight line. That means we really don't want any x squareds in there because they're going to give rise to curvy bits. So if x squared minus x minus 1 is 0, let's multiply through by 2. 2x squared minus 2x minus 2 is also 0. Multiply both sides by 2, and 0 times 2 is 0. So our graph that we've got is 2x squared minus 4x minus 1. And we want to know, right, when we draw this line out, and it's actually this, but I haven't arrived at that yet, it's going to be, we want where it is, it's going to be where the straight line crosses with each other. That's where the x values are going to be. So we need to find the straight line. So it's 2x squared, if this is the curve we've got already, then set it equals to ax plus b, which is a straight line. Ignore that there. That comes back at the end. So we've got 2x squared minus 4x minus ax on that side, minus 1 minus b on that side is 0. So this is 2x squared minus x times 4 plus a, because we've taken the minus outside the bracket, and then minus 1 plus b equals 0. So if we compare this with what we want up here, this is what I had the colour before, 4 plus a is equals to 2. Okay, because that's there the x's. The x's here, we've got the minus x there, so it's the 2, has to be the 4 plus a. Let me get a small colour again. And then the next bit here, this 1 plus b has to be the 2 there. Okay, so a is minus 2 and b is 1. And then I go back here and I put a is minus 2, minus 2x plus 1 is going to be your, that's the straight line that we need to draw. Draw the line y equals minus 2x plus 1 from there's there. Okay, so I picked some points here, and again this scale caught me out when I first did it. I don't know what it was. It's because this way, look, it's 5 little squares is 1, but this way 10 little squares is 1. So just be careful of that, don't be caught out. Anyway, so plot some points. X is minus 1, y is 3. X is minus 1, minus 2 times minus 1 is plus 1. Sorry, it's plus 2, plus another 1 is 3. So that one's there. X is 0, y is 1. X is 0, y is 1. And x is 1, y is minus 2 plus 1, which is minus 1. So put the 3 crosses and draw the line. And then you work out the actual answer, where they're equals to each other, where they cross. Plus 1.6. And then minus 0.6. It's just on my graph. It's just closer to, it says to 1 decimal place. So, okay. Right, here is a rectangle. The area is less than 75 centimetres squared. Find the range of possible values of x. So the area, we multiply these together. It's going to be less than 75. So multiply out 2x squared plus 3x minus 2x minus 3 and minus 75 there, look, is less than 0. So I've got 2x squared plus 1x, 3x minus 2x is 1x, minus 78 is less than 0. Now, I don't know, do you get the quadratic formula in your... yeah, use the quadratic formula there. We've got a quadratic set equals to 0, so I've used this here. A is... Now, I'll just go back to where I was because, you know, you can copy that across. So we've got A is 2, B is 1, C is minus 78, and it's the formula that you can copy across. It's minus B minus 1 plus minus the square root of B squared, 1 squared, minus 4 times A, 2 times C minus 78, divided by 2A, which is 2 times 2. It's minus 1 plus or minus the square root of 625 when you work that out. I think I must have done that up there, look. 78 times 8, yeah. That's a times there. It's 624. And it's minus 64, but then it's minus 64, so it's plus. So it's 625. So x is minus 1 plus or minus 25 over 4. So x is minus 26. Minus 1 minus 25 is minus 26 over 4. Or minus 1 plus 25 is 24 over 4. So x is minus 6.5, which is not applicable in this problem, because we would have negative lengths of sides there, which we don't want. Or x is plus 6, so we're happy with that. So that means, x is equals to 6. It's got to be less than 0. Look, I put less than or equals to. It should be just less than there, because it's less than up there. So for this here, this is the curve 2x squared plus x minus 75. The reason why we did this, we was finding where the quadratic equals 0. Okay, so it's less than 0 between minus 6.5 and plus 6. So the possible values of x, we don't want negative ones anyway. We don't want 0. So x is between 0 and 6. Okay, number 23. We've got a triangle PQR. PQ is 1.6. PR is 4.2. P to R to Q, angle is 18. PQR is obtuse. That means it's greater than 90 degrees or less than 180 degrees. Between 90 and 180. Not or, less than, and. So it's between. Work out the area of the triangle. Give your answer corrected. 360. So down here, I've got the area formula. Let's use a different colour. Let's use a different colour. The area. It's a half AB sine C. And again, that's on the front cover. That's on that sheet at the front. Half AB sine C. Okay. But we've got A and B here. This is the A and the B. The C has to be the angle between them. So we need this angle here. We need the angle at P. Okay. So we want the angle at P. We've got this ratio. We can use this here to work out the angle at Q using the sine rule, because we need a side and its opposite angle. So we've got sine Q over 4.2 is sine 18 over 1.6. So sine Q is 4.2 sine 18 divided by 1.6, calculator. So sine Q is that, and that's off the calculator. So Q is sine inverse. I press answer for the answer button on the calculator. And it comes up as 54.2. But that's acute, that's not obtuse. So to get the next one, you've actually got to do 180, take away the answer on the calculator, which will be 125 point blah, blah, blah. So the angle at P is now 180, take away the 18, take away the answer on the calculator, and it comes up as 36 point blah, 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 blah. So the area is a half That's going to be the 36.210 blah blah blah. Okay, so it's a half AB sine of the angle between them. So it's a half of 4.2 times 1.6 times the sine of that answer. And it's 1.98. Look, they want three significant figures, so it's 1.98. Okay. How many have we got to do? 24, 25, 26. We'll get there. Okay, 24. I've just done them twice. I think I might have actually done some of these 3 times from messing around. But anyway, we're doing it now. Particle P moves along a straight line that passes through the origin. Displacement x of P from the origin at time t for positive t is given by x is 4t cubed minus 27t plus 8. Direction of motion of P reverses when P is at the point A on the line. I've circled all the important bits there for me. The acceleration of P at the instant when P is at A is a meters per second squared. Find the value of A. So started with, this is the direction of motion reverses. That's when the velocity, or dx by dt, is equals to 0. So you've got to know that. Okay. Dx dt, so now I've moved on to this one. The power multiplies the number that's there already, 12t, and the power drops by 1 there, squared. Minus 27, because it's t to the 1, so it comes minus 1 times 27, minus 27, t to the 0, which is 1. And 8 differentiates to 0. And so we want this to be 0, so 12t squared is 27. So t squared is 27 over 12, which is 9 over 4. And t is plus or minus 3 over 2. And this is why I've circled this one. T has to be positive, so t is plus 3 over 2. Now for the acceleration, we have to differentiate again. And that's what we need, you see, the lowercase a. So it's 24t, and that differentiates to 0. And we know t is 1.5, so acceleration is 24 times 1.5, which is 36. And the units, meters per second squared, don't forget to carry those units down there. Okay, 25. Function g is defined as maps x onto 5 plus 6x minus x squared, where x is greater than or equals to 3 for the inputs. Okay, so g, okay, so I'll put some examples here, because some people find this hard. If x is equals to 3, g of x is 5 plus 18, which is 23, minus 9, which is 14. If x is 10, it's 5 plus 60, 65, minus 100, minus 35. Okay, so it's just some examples of what's going on there. So domain means that's the input, so we can't put anything less than 3 in. Express the inverse function g inverse in this form. Okay, so the way that, there's a couple of ways of doing this, but this is the way I decided. Y equals 5 plus 6x minus x squared. Okay, what I'm going to do is rearrange this to get an x equals. Okay, the way that I do it. If your teacher does it a different way, that's good, as long as you get the answer right. Right, I've multiplied both sides by minus 1. I'm going to complete the square here, and that's to get this to be a plus here, and I'll change it back at the end. So minus y is plus x squared minus 6x minus 5. Minus y, completing the square, this is going to be x minus 3 squared. That's going to give us x squared minus 6x. But it also gives us plus 9, but we want minus 5, so we've got to take away 14. Then I multiply back again by minus 1. So y is minus x minus 3 squared, and then plus 14. And then, so we still haven't done, we're still working on this here. What we do then to find g inverse, I'll put that there, because this looks a bit weird otherwise. We switch the x for the y, so that is g, we're still up there. That's still g, that's just rearranging this. It's getting something we can work with. We switch the x and y to find g inverse, x on that side, y there. Then I've written that side over there equals x. So I've got minus y minus 3 squared is x minus 14. So multiply both sides by minus 1 again. Y minus 3 squared is plus 14 minus x. So y minus 3 is plus or minus the square root of 14 minus x. And then we add 3 to each side. Y is 3 plus or minus the square root of 14 minus x. So what I used then to decide whether it's plus or minus, I went back to these. So if we put x is 10 in the original, we get minus 35 out, say. So if we put minus 35 into the inverse, we need to get 10 out. So 3 plus or minus 14 minus minus 35. So that's actually plus, that's 49 under there, and the square root of 49 is 7. And we want it to be 10, so it's going to be 3 plus 7. So that's why I picked the positive one there. Okay, so G inverse is such that x maps onto 3 plus the square root of 14 minus x. Last one to go here. This one got a bit messy. Anyway, an arithmetic series has first term A, common difference D, where D is a prime number. The sum of the first n terms of the series is Sn. Sm is 39, S2m is 320. Find the value of D, the common difference, and the value of m, which is the number of terms. So this here, again, that's in your formula sheet at the start. Okay, so I didn't show you before. We have used the area of a triangle in that last question. That's in there, the sine rule. I can't remember if I've used the cosine rule, but it's in there. We've used that one in this exam. And then it's this one, I've already coloured it in here. This is the one that we need, though, for this question. Sn is n over 2, brackets, 2a plus n minus 1d, close brackets. Right at the end there. So I copied it across. Okay, so you don't need to memorise that. Some exam boards, you have to memorise that. So, you know, it's a bit of a... It's an interesting feature of this exam. So there we go. So the first one, we've got m, we've got Sn is this, but we've got n is equals to m here. So we've got to put an m everywhere there's an n. So m over 2, 2a plus m minus 1d is 39. Okay, so that's using that bit. You've got n equals m in there. And then with a double star here, well, the double star one, that's going to be the 320. I'm not quite there yet, but I'm going to use that one in a minute. I've simplified this now. Multiply out by m over 2, so that's am. And then it's m over 2, m minus 1d. Multiply out the brackets, equals 39. Call that equation 1. Then double star. We've got, in that one, you let n equals 2m. So we get 2m over 2, look, this is 2m there, so n is 2m here. 2m over 2, 2a plus 2m minus 1, d is 320. They cancel on that other side, because that's in the formula, and that's when they're coming through. So we've got 2am plus, there's just an m there, m 2m minus 1d is 320. So there's equation 1, but I've doubled it. And I've doubled it so the 2am is the same in both. So it's 2am plus m minus 1d, doubled that, equals 78. I've doubled that. And that one I've written the same underneath. Then I do equation 2, take away 2 times 1, which is here. So they cancel. And we've got 2m squared minus md on that side, minus m squared d, minus md there is 242. And if we look here, we've got minus md there, and minus minus makes a plus md there. So they cancel. So we've actually ended up with 1m squared d is 242. And we know one of them here, d is a prime number. And that made me think, right, prime factorisation then. So d's got to be a prime number. So this is 2 times 121. 242. So it's 2 times 11 times 11. So we've got 11 squared times 2 is 242. So m is 11 and d is 2. 11 and 2. Okay, so that's a good question. It's a good exam. I enjoyed doing this. Twice. Anyway,